Okay, let's unpack this. Welcome to the deep dive. Today, we're plunging into a document that feels, well, incredibly timely.
Hmm.
It's a record from a recent consultation session, and it dives deep into how artificial intelligence tech could be applied to a very specific, very real-world problem.
And the core issue they were grappling with is something, a lot of institutions face, managing intellectual property, specifically patents,
Right.
and trying to figure out if researchers are pursuing patent applications on their own, sort of outside the official channels.
Uh-huh. And whether those patents are actually connected to their work at the institution.
Exactly. Connected to institution-backed work.
Yeah.
It's tricky.
Think of it as like a compliance check, but it's scaled up. Our mission with this deep dive is to pull apart this consultation record. We want to see how AI is being eyed as a solution to what sounds simple on paper,
Yeah, sounds simple.
but, as you'll see, gets incredibly messy and difficult in practice.
Oh, absolutely. Especially when you hit the administrative reality, trying to manually track down patents and match them to people.
Yeah.
Particularly when you've got common names floating around, it can be a total nightmare.
Okay.
That's where the manual grind the document talks about really sets in.
So tell us about that pain point. What does this source actually reveal about the current, the non-AI process they're using?
Well, the document details the current situation pretty clearly. This institution, they need to regularly check if their researchers are applying for patents without reporting them.
Okay. Standard procedure, kind of.
Yeah, it's a necessary check. Protect institutional IP, understand the research impact landscape, all that.
And the way they actually do it now.
It's basically a brute force manual effort.
Oh, boy.
They select a small random percentage, just 5% of researchers from certain units each year. Then someone literally has to manually search patent databases for those names.
Okay, right away I can feel the pain. Just 5% and it's still manual. What are the absolute worst parts of that, according to the consultation?
Well, top of the list is efficiency, or, the lack of it. It's incredibly time-consuming.
I bet.
But the real headache, that comes with common names.
Yeah.
Imagine having, 50 Live Ice or Maria Garcias across different departments.
Ooh.
How do you possibly figure out which one, if any, might be linked to some patent application you found?
You just triggered my administrative dread. Seriously. And even if you do find a patent with a name match, you then have the job of figuring out if it's actually related to that specific researcher's expertise, their actual work.
Exactly. That's the next hurdle. Manually comparing the technical details of a patent to a researcher's profile, their publication history.
Yeah.
It's slow.
And probably not super accurate.
Well, it's prone to error, yeah. And the source points out that relying on simple tools like just pulling names into Excel and doing manual lookups, the accuracy is pretty low. And frankly, it's a huge drain on human resources.
Right.
You're essentially digging through haystacks, hoping to spot a specific needle based on what? A hunch and a name match. It's not efficient.
That really paints a picture of the difficulty. Okay, so faced with this time sink and the common name conundrum, the team started dreaming. What could AI do if it worked perfectly? What was on their AI wish list?
The core desire was automation, definitely, but smart automation. They hoped AI could automatically search for and, crucially, match researcher patent applications.
But they weren't looking for any old patent match where they had to be specific.
Oh, crucially specific, yes. They wanted AI to identify patents applied for during the researcher's employment period. That's key.
Okay.
That were not reported to the institution. Another key filter, and this is the big one, that were highly related to that researcher's specific research field.
That highly related part, that's the golden ticket, isn't it?
That's it. That requires real understanding, not just keyword matching.
And the common name problem, how did they hope AI would tackle that?
This is where the AI needs to be, clever. They wanted the AI to help differentiate between researchers with the same name by looking at contextual information. Things like the technical fields mentioned in the patent itself, and, maybe most importantly, the researchers' documented publication history, their papers, their articles.
Okay. So building a kind of unique fingerprint beyond just the name.
Exactly. That helps profile them properly.
And presumably they wanted it to keep things up to date automatically, staff changes, things like that.
Oh, yeah, absolutely. Automating the process of adding new staff and removing departing ones from the tracking list was definitely on the wish list. Avoid that constant manual list management.
Okay, so the vision is fully automated, smart matching, understands expertise, navigates identical names, stays current. Sounds great.
Mm-hmm.
But as anyone who's tried to implement new tech knows, the dream meets reality pretty quickly.
Mm-hmm.
What were the key technical hurdles, the practical questions that came up in this consultation?
There were a few major ones. First, the foundational question. Where does the patent data actually come from?
Right, data source.
They discuss different options, contrasting something broad like Google Patents with a more official national database. The source mentions the Taiwan Intellectual Property Office, the OSRU as an example of a national one.
And the choice matters because
Reliability, completeness, those are critical for accuracy, data quality in, results quality out.
absolutely,
But
garbage in, garbage out, standard rule.
exactly. Then there's the challenge of getting the internal data ready.
Ah, the institution's own records.
Yeah.
Ugh.
Is it easy for them to get comprehensive, well-structured lists of all researcher publications? Do they have clean lists of patents already linked to researchers? Getting that internal data set organized, clean, usable, it's a huge prerequisite, often underestimated.
Definitely. And if you're asking AI to do that complex technical matching, read a patent abstract, read a bunch of papers and say, yep, these look related.
Yeah.
How do you even tell what to look for effectively?
That brings up the whole importance of the prompt.
Trumped engineering.
Exactly. How do you formulate the instructions you give the AI? It's not enough to just dump data in front of it. You need to ask the AI the right question in a way it can understand and act upon to accurately compare those technical domains.
Fascinating. So, okay, they laid out the problem, the AI dream, the practical challenges. What was the proposed solution? The architecture they landed on.
The recommendation that came out of the consultation was basically a two-phase approach.
Okay, let's break that down. Phase one, what's that about?
Phase one is focused on data automation and that initial filtering step. The idea is to build an automated system. They mentioned using AI or maybe robotic process automation, RPA.
RPA, right.
Right.
Software robots doing repetitive tasks.
Exactly, like mimicking human interactions, copying data, filling forms, searching databases. So this system would regularly pull patent application data from specified, reliable public databases based on the researcher names they have on file.
So the goal of phase one is just to scoop up everything that might be relevant, cast a wide net automatically.
Precisely. It's about automating that first, incredibly tedious search step. The system would then filter this down and produce what they called a suspicious list.
Suspicious list.
Yeah, basically patents found under matching names but without a clear existing link in the institution's own records. This drastically cuts down the volume of stuff a human has to look at initially, reduces the manual effort of just finding potential patents.
Okay, so phase one handles the mass searching and initial filtering. That alone sounds like a huge efficiency gain.
Definitely.
What about phase two? The deep technical matching part.
Right, this is where the more advanced AI capabilities come in. The source specifically mentions using a powerful AI model, like ChatGPT, maybe even GPT-4.
Okay, the big language models.
Yeah, models known for their ability to understand and synthesize complex text. This AI takes that suspicious list from phase one, and it cross-references the technical details of those patents against the researcher's publication list, their body of academic work.
So the AI is essentially reading the patent, reading the researcher's papers, and looking for a connection, like conceptually?
Yes, exactly. It's looking for technical domain overlap, potential derivations, thematic links. The AI's role here is to quickly identify which patents on that suspicious list are potentially undeclared and seem highly related to the researcher's documented expertise based purely on their publications. It's doing that complex comparison that's so time-consuming manually, but doing it at scale.
And what does the AI give you back? What's the output of phase two?
It provides clear comparison results, and this is key. The document stressed it should provide the reasons or the basis for its findings, why it thinks there's a match.
Explainability. Important.
Very. But this output, the potential matches and the AI's reasoning it, isn't the final answer.
Oh.
No, it's then passed on for a crucial final human review and confirmation step.
Okay. So it's AI augmenting the human experts, not replacing them entirely. That makes a lot of sense.
Exactly. It handles the heavy lifting, the initial analysis.
Now, we talked about data readiness being a hurdle. What did the consultation actually recommend needed to happen before you could even think about plugging this system in? Preparation steps.
Yeah, data prep is absolutely foundational for this whole thing to work. The first recommendation was about meticulously organizing and compiling comprehensive publication lists for every single researcher.
And getting specific details, right?
Yes, they specified needing things like title, author, DOI.
The digital object identifier, yeah.
Right, that unique link.
Oh,
Also, publication year, journal name. The more detail, the richer the data for the AI's technical comparison in phase 2. It needs that granularity.
makes sense. And keeping the list of researchers themselves accurate and structured.
Essential, absolutely essential. Regularly getting updated lists of current staff, and ideally getting them in a structured, machine-readable format like a CSV file. That was highlighted.
Why CSV?
It just makes it much easier for the automated system in phase 1 to ingest the data and know who it's supposed to be searching for. Less manual formatting needed.
Got it. And looping back to the patent data source for phase 1, they had a recommendation there too.
Right, they really reiterated the need to use highly reliable, official, public patent databases. Like that Ministry of Economic Affairs Intellectual Property Office example. The goal is to ensure the highest possible accuracy for that initial automated name search. You don't want your suspicious list filled with junk or irrelevant noise because you used a flaky data source.
Yeah, that would defeat the purpose. This all really emphasizes that AI solutions aren't just about the fancy model, are they?
Not at all.
They're built on a foundation of good data, good process design.
Absolutely. Data and design first.
Let's go back to that prompt idea for a second. You said the source actually gives a specific example of the kind of instruction you'd give the AI for phase 2.
It does, yeah, and it's a great illustration of how you guide the AI. The suggested prompt, paraphrased slightly, is something like, using researchers' names data, infer from their publication list which patents in the suspicious list might be derivations of their research and explain why.
Infer and explain why.
Wow.
Wow. That's doing a lot more than just basic keyword matching. It's asking the AI to actually draw conclusions based on a whole body of work and then justify those conclusions.
Precisely. It shows you're instructing the AI to perform a level of analysis that mimics, how a human expert might connect the dots. Looking at technical concepts, research themes, not just simple text similarity, it's a clear example of how crucial that prompt crafting is for guiding the AI's complex reasoning.
Okay, so we've covered a lot. We've journeyed from the manual pain of hunting patents for common names through the hopeful vision of AI automation, explored the practical data hurdles, mapped out this two-phase AI-RPA solution,
Right.
stressed the importance of data prep, and even saw a concrete example of how you ask the AI to do the heavy lifting. So let's bring it back. What does this specific deep dive into this consultation record really mean for you listening right now? Why should you care?
Well, I think this isn't just about patents, really. This is a powerful real-world case study. It shows how AI is being seriously considered and likely deployed to tackle these administrative tasks that are just drowning in data and complexity when done manually.
Yeah.
It illustrates that AI's strength isn't always in the super flashy applications we hear about, but also in cutting through information overload in very specific, practical domains, like identifying connections between patents and research.
It really highlights the power of breaking down a complex problem, like, is this patent related to this person's decade of research,
Yeah.
into manageable steps, right?
Yes.
Phase 1 handles the finding, phase 2 handles the understanding. And it shows how AI can perform that nuanced, complex matching based on specific criteria like publication history and technical domain that humans struggle to do quickly and consistently at scale.
And I think the core takeaway that really resonates from reading this document is the absolute non-negotiable importance of both things. Having the right data ready, structured, clean, comprehensive, and knowing how to ask the AI the right questions. Good prompt engineering. The success of something like this really hinges on both the quality of the input data and the intelligence of the prompt you give the AI.
It's a fantastic look at AI as an enhancer, really, a force multiplier for human expertise. We've seen how AI, and even simpler automation like RPA, can take over the exhaustive search and that initial complex analysis. But thinking about that proposed two-phase system where the AI does all that heavy lifting, it leaves us with a pretty compelling thought, drawn directly from this source.
Yeah.
Given everything the AI is doing, the searching, the comparing, the explaining, what is the essential, irreplaceable role that human expertise still plays in this entire proposed system?
That's a great question. And the answer comes right back to that final step we mentioned.
The human review.
Exactly. The AI identifies potential links. It provides its reasoning based on the data it was given. But the human expert provides the ultimate judgment call. They bring the context, the nuance, maybe institutional knowledge the AI doesn't have access to, and they make the final confirmation.
So the AI can't fully replicate that final decision.
Right. The AI finds the needles in the haystack and tells you why it thinks they're needles, based on the patterns it sees. But a human still has to pick them up, look closely, and say, yes, that's the one we need to look into further, or no, this isn't relevant despite the similarities. That judgment remains human.
A really clear picture of practical AI integration. Well, thanks for joining us for this deep dive today.